Imagine for a moment. The compass you hold in your hand has been humanity's most trusted guide for centuries. When it pointed north, no one questioned it, because north was always there. Or was it really? At the heart of the Earth, molten iron oceans are in constant motion. This invisible flow creates a giant magnetic shield around our planet. This shield not only guides our compasses, but also protects us from the deadly particle storms of the sun. Yet, right here, a secret is hidden. The North Magnetic Pole is not fixed. In the past century, it quietly broke away from Canada and began accelerating toward the Taimyr Peninsula in Siberia. This drift has gained extraordinary speed in recent years. The reliability of compasses has come into question, and precise adjustments have become mandatory in many areas from aviation to military systems. For example, in the early 2000s, some small airports in Alaska had to update their runway numbers according to magnetic north. This was a critical safety measure for aviation. So what does this drift mean? What happens if your compass takes you in a completely different direction one day? If aurora lights shift to other continents, how will our sky change? Moreover, if Earth's magnetic poles completely reverse one day, how will civilization be affected? The drift of the invisible force, the magnetic field, is much more than an ordinary geological event. Earth's surface may seem safe, stable, and calm to us, but beneath the surface, about 3,000 kilometers deep, lies the planet's greatest secret, the outer core. This region is made of a boiling mix of liquid iron and nickel at temperatures between 4,000 and 6,000 degrees. The intense convection currents here, molten metals moving up and down due to temperature differences, create massive electric currents, and the combination of these currents gives birth to Earth's magnetic field. This process is explained by dynamo theory. Just like a small dynamo in front of a bicycle generates electricity with wheel movement, Earth continuously creates its own magnetic field through internal motion. But the scale of this dynamo is incomparably larger. This field forms a giant shield called the magnetosphere around Earth. Most of the high-energy particles from the sun are deflected by this shield. Without the magnetic field, our atmosphere would erode rapidly, and the surface would be scorched by deadly radiation. During the famous Carrington event in 1859, if it weren't for this magnetic protection, modern telecommunications and electricity networks could have nearly collapsed completely. The magnetic field does not exactly align with Earth's rotational axis. That's why the geographic and magnetic poles are at different points, and these poles do not remain fixed over time. They continuously drift like the needle of a giant compass. Geological records show that for millions of years, the magnetic poles have not only moved but occasionally reversed completely. One of the best-known examples is the Brunhes-Matuyama reversal about 780,000 years ago. At that time, the north and south magnetic poles switched places, introducing Earth to a completely different magnetic order. In more recent history, the Lasham event about 41,000 years ago indicated a brief reversal. Interestingly, life continued during these events. Although magnetic change leaves traces in geological records, human civilization has survived. There are two significant concentrations in the distribution of the magnetic field, the Canadian lobe and the Siberian lobe. For centuries, the Canadian lobe was dominant, keeping the North Magnetic Pole stable near Canada. But in recent decades, the Canadian lobe has weakened, while the Siberian lobe has strengthened. This imbalance caused the pole to break away from Canada and accelerate toward the Taimyr Peninsula. Scientists attribute this change to a reorganization of currents in the outer core. Molten iron at Earth's heart moves slowly but powerfully, redrawing our planet's magnetic map. This dance has sped up over the last century. In the 1900s, the North Magnetic Pole was still near Ellesmere Island in northern Canada. From the 1990s, the drift accelerated, with speeds rising from a few kilometers per year to tens of kilometers per year. In 2019, it sped up so much that scientists had to update the World Magnetic Model. Today, the North Magnetic Pole has left Canada and is heading toward the Taimyr Peninsula in Siberia. Interestingly, in recent years, there have been signs of some slowdown. The pole does not just follow a linear path, it sometimes speeds up, slows down, and partially changes direction. The drift of the North Magnetic Pole is not just a topic for science labs, it affects daily life as well. Modern GPS technology relies on satellites, but compass reliability remains critical. Runway numbers at airports have to be relabeled because of the drift. For example, Denver International Airport had to update its runway numbers twice in the last 20 years. Smartphone compasses are constantly updated to compensate for such drifts. Accurate magnetic data is vital for research vessels, icebreakers, and military elements operating in Arctic regions. This invisible drift leads to small but critical adjustments in the infrastructure of modern civilization. The magnetic pole affects not only the land but also the sky. As the pole shifts, the aurora belt moves with it. The aurora borealis is a visual spectacle created by solar particles entering Earth's atmosphere along magnetic field lines. As the pole moves, the regions where these lights are most often seen also change. Auroras that were once rare in northern Norway have recently been observed as far south as Scotland and in more southern parts of Canada. Additionally, magnetic field imbalances can increase the impact of geomagnetic storms. During the 1989 Quebec storm, which struck when the north magnetic field weakened, the electricity grid collapsed, leaving millions without power. Risks also increase for astronauts as the magnetic field serves as a shield in low orbit. So what happens if the pole continues to drift like this? In the simplest scenario, the North Magnetic Pole keeps moving toward Siberia and could fully migrate to the Asian continent within a few centuries. In a more dramatic scenario, the currents in the outer core may fail to establish a new balance and the magnetic field could weaken. This would affect many systems, from satellite technology to electricity networks. The most dramatic possibility is a magnetic pole reversal. This process takes thousands of years. The field could weaken, creating a more vulnerable period for humanity. The drift of the North Magnetic Pole toward the Taimyr Peninsula is not just a geographic event. It is a story still being written along with humanity. The actors in this story are the molten irons boiling in Earth's core, the auroras shining in the sky, and our technology-dependent civilization. Today, many pieces of the puzzle are still missing. Will the pole slow down, speed up, or is reversal near? While scientists search for answers, we continue to trust our compasses, phones, and satellites. And in the midst of all these invisible forces, a reminder emerges that will help humanity find its way. Understand Earth's invisible shield, direct your future. Don't forget to like the video, subscribe to the channel, and share your thoughts in the comments so you don't miss more of these fascinating science stories. We're curious about your opinions concerning Earth's invisible shield.